Hello, and welcome to our second webinar on harnessing the power of your 8800 controller for intermediate users. And if you attended our seminar for beginners 2 weeks ago, welcome back. My name is Mark Pike, and I'm the marketing manager at Thermotron. And our presenter today is Chris Colton, a sales manager at Thermotron and an expert on the 8800 controller. We're excited to have you, and we hope you enjoyed today's webinar and you get a lot out of it. Before we get started, I just wanted to let you know that we will be muting everybody during the webinar in the presentation, but we will be still taking questions throughout. So if you have a question, feel free to use the chat feature in the chat window on the GoTo training panel and send it over to our organizer, Jane Newton, and she will compile the questions and we'll present them to Chris at the end of the webinar, and we can kind of go over them at that point. All right, well, let's get started, and I'm going to hand it off to Chris. So here you go, Chris.
Thanks, Mark. Good morning, everybody. Thanks for joining us. What I wanted to get started with first is we had a couple of really good questions last session, and I just wanted to expand a little bit more to try and address a couple of those things. Okay, one of the first items is a couple of weeks ago we went through all the different parts of the 8800, the touch screen, which all of you are likely familiar with. And then there's the single board computer where the software resides. It's where all of the inputs and outputs are that you see here on the screen. And somebody asked about, hey, I'm hooking this up to our network. IT is telling me I have to have antivirus on it. How do I install that? And the general answer to that is we really don't allow you to do that. The answer that satisfies most IT people is that the version of Windows that we're running in the background is called Windows 7 Embedded. And what that is a special version of Windows created for OEM manufacturers like ourselves. The other big application for it is with ATM machines. So it's a very, I'll say, stripped down, secure version of Windows that is generally thought of as hacker-proof, if you will, or virus-proof. So it doesn't have a lot of those things running on it that make it susceptible to those type of things. So in general, if you talk to tech support, they'll say, hey, we really discourage it. There's a lot of good reasons not to have it on there. It takes up resources. It can cause unknown conflicts. But if it's something you can't get by with that answer to your IT people, we will work with you and try and offer up some suggestions on things you can do or give you access to that window so you can go ahead and install that on there kind of at your own risk. The other thing I wanted to mention is the software that we're running today is a little bit an older version of the software, so you might even see some things on your own 8800 if you've ordered one in the last 6 months that you won't see here today. And I'll just mention if you have a real old version, you can update your 8800 software at any time. And to do that, you would just go to our website, thermotron.com. There's a service tab, and under that service tab, there's a section called software updates, and you simply fill out your email address, contact info, and then we'll give you a link on where to download those. So we have one for the 8800, the 8825, our AST software, 3200, 8200, all the controller softwares are there. And on the 8800, to update that, all you would do is select the access icon that you see on the screen now. And it really doesn't matter what access level you're in. You just simply type update into the password section. So, and it's got to be in all capital letters, so UPDATE, and select OK. And if you have the update file on a USB flash drive that you downloaded from our website, it will go out, find that file, and update your software automatically. And that takes about 15 seconds. None of your existing programs, settings, or anything will be affected, much like when you update your Windows software at home. It doesn't go into any of the files and change anything or any of the configuration. It just simply updates the executable and adds in those new features. So again, just go to the website. It's on there. Download it, throw it on the root directory of a flash drive, plug it into the 8800, type in update, and you'll have the latest and greatest software. So the next thing I wanted to cover is a couple weeks ago we did a basic program just to give everybody a feel for how you write a program. We kind of showed you the wizard, how to create a profile using that, especially if you're a very occasional user. And I just wanted to touch base on some of the nuances of programming and some of the more advanced things you might run into if you're given a lot of different test specs and there's a lot of variables you're trying to program at the same time. So some more advanced concepts. So if you're following along with your demo software, you would just simply click on Program. So to write a new program, we would select New down in the bottom left. And once you have a new program, this will change from the previous program to untitled, telling us it's a brand new program. So what we'll do, a couple weeks ago, we just created a simple temperature profile. Right now, we're going to do some more complex programming just to show you some of the things you might run into. So first of all, like we talked about previously, when you're setting up a profile, you really need to determine whether you're going to control just off of air temperature or if you're going to use product temperature control. And if we select the product temperature control channel, now you'll see it goes from air temperature to load temperature or PTC. One gotcha there is if you're going to be doing humidity testing, PTC is not an option. And the reason for that is humidity is controlled based on relative humidity, and it's relative to the air temperature. And when we program in product temperature control, it controls everything based on the product. And a lot of times, in order to get the product temperature to do what you want it to do, the air temperature might be somewhat erratic. And if you're trying to control humidity at the same time as a somewhat erratic air temperature, your relative humidity would be all over the place. So the simple answer is humidity and product temperature control are incompatible. So anytime you're using humidity, the PTC will be grayed out, and then anytime you're using PTC, the humidity would be grayed out. You can switch back and forth. So if you wanted to do a profile with product temperature control during the first part of it and then switch over to humidity later, that can be done. It does create a little bit of control issues when you're switching over, but it can certainly be done. If you have any other questions or want more explanation on that, shoot us a note, and I'll be happy to provide more explanation. So for this test, we're just going to set one up with temperature and humidity. So for step one, we're at interval 1 of 1. Generally, we want to put in, start off at an ambient condition. So we'll just call it 25. And what I like to do is, because when you're starting a test, you really don't know what the current condition is, I like to get things stabilized first. So you can do that simply by putting in an initial value and a final value the same. And to guarantee that we get to this condition, one way would be is we could just hold it for 15 minutes. That would give it a chance to stabilize. The other good way of doing that is we can just simply put in a deviation, say 2 degrees, with a G-soak and add in a time of 1 minute. So now what's going to happen is it will drive to 25, and then once it gets within 2 degrees, then it will stay there for 1 minute and then move on to the next step. And that just gives us a nice starting point. So if the previous user was running the test, left it really hot, this will get it back to an ambient condition so you can move on with your test. So we'll just, I'm going to turn humidity off for this step. We'll insert that as a step. So now we're on 2 of 2. So after that 1 minute at 25, it'll move on to this step. So now we'll begin our humidity profile. So the condition I want to go to is 85 degrees C, 85%. So to do that, we would put in 85 degrees C for our final temperature. For this example, I'm going to get rid of the deviation because our test spec doesn't specify a tolerance. And then our relative humidity, we're also on at 85 or 85%. So a real common test spec called damp heat, 85C, 85%. So if we leave the ramp rate at 0, that means that it will change as soon as it moves on to step 2. It's going to change the set point instantly from 25 to 85, and it will change the humidity value instantly to 85, and then the chamber is going to try to drive there. If our spec calls for a ramp, then we would put in a ramp rate here, and this is degrees C per minute. So let's just say 5 degrees C per minute, and that comes out to 12-minute ramp. Now, one thing to be aware of here is that time applies to both variables. So if this were a test, it moves on to step 2, the temperature would ramp up at 5 degrees C per minute, but understand that the humidity would also ramp at the 12-minute ramp time, or in this case, 7.1%. And the gotcha here is we put in an initial value of 0%, or that was carried over from the previous step. So what would happen is the temperature would be at 25, and after a couple of seconds, it would be at 26 degrees C. But the humidity would be at 1%. So the chamber would actually try to dry out during those initial few minutes. And that's realistically not what we want. So to correct that, we would go back to step 1. We could add in humidity here, put in 85%. And that would carry over now into the next step. So now it would start at 85, finish at 85, and that would give us what we're after, which is driving to that 85%. So the lesson here is understand that anytime you're ramping, it's going to apply to both variables. Now, there's a lot of times when I'm running a test where if you've done any amount of humidity testing, you know that ramping in temperature and trying to control humidity are somewhat incompatible because it's not a linear function. Relative humidity isn't a linear function, so it has a really tough time trying to hold a humidity level while you're changing a temperature. So a lot of times for these tests, what we would do is do them separately. So we would ramp up in temperature, simply turn off that humidity channel, and then in step 3, that's where once we've reached 85, now we'll turn on the humidity and drive that to 85%. One of the other things I wanted to show you is with guaranteed soak, and we'll just start a new test here. So we'll have an initial value of ambient, a final value of 85 degrees C again. I'm going to put in a deviation. So we're going from 25 to 85, and we're saying once we get to 2 degrees C, then we'll move on to the next step. You also have the option here of combining both the ramp and the dwell together at the same time. So if we put in 10 minutes here, and we have a guaranteed soak, this is now a soak function. So what the chamber is going to do is ramp from 25 to 85 as fast as possible, because that hidden ramp rate here is 0. And then once it gets within 2 degrees C, then it will soak for 10 minutes. And this is a little bit, you need to be cautious doing this, because if you forget to check the G-soak box, now this becomes a ramp from 25 to 85 over 10 minutes, which converts to 6 degrees C per minute. So you can kind of see that by hitting the G-soak, now it's a ramp as fast as possible, and then soak for 10 minutes. If we uncheck it or change it from a soak to a ramp, now it gives us a ramp rate of 10 degrees C per minute. The other thing I wanted to mention to you is with looping, you can put in a loop. If you have a certain profile, you can loop it, and you can actually do multiple loops within the same program. So if we had a simple profile, we could loop that 10 times, move on to a different set of temperatures, loop that several times, and then even at the end of the program, you could loop the entire thing over several times. So you can have what we call nested loops, or loops within a loop. And again, anytime we write a program, we simply go up and save it. We'll save this as test 1. And to run the program, you select Run, select your profile. You would find that test. And again, we have the option of a delayed start. So if you wanted to have this test start at midnight, have it finishing up when you come in the morning, you can select that, pick the time, and then when you hit start delay, it won't actually start the test instantly, but instead it'll start it at the time that you have selected there. So we'll select Run. It will start the test. And one interesting thing you can do while you're running a test is at any point you can stop it or put it into a hold. So this interval that we created was, again, that ramp from 25 to 85 over 10 minutes. So you can see here that it's ramping at 6 degrees C per minute, or the set point here is ramping at 6 degrees C per minute. So if we wanted to hold this, and this is a common thing that I'll do in the lab, is press hold. And I really don't want to wait this entire 10 minutes because we're already at temperature. So what you can do is press Edit. You can change this to a lower value. Select OK, and then Run. And now it just trims some time off of your test profile. And it doesn't actually change the program, it just changes this instance that's running. So the original program's unchanged, it just allows you to change an interval or change the amount of time in it. You even have the option of holding and then switching over to manual mode, and you could ramp up to some temperature. And a common example for this is you're running a test, you see something happen with your product, a wire fell off or it stopped working, you want to swap it out. You can hold the program, go over into manual mode, drive it back to ambient, and then go back and resume the test. The other thing that's not shown on this this version of the software, but recently we've added in the ability to resume a test if it did not complete all the way. So if you have to stop a test for some reason and you want it to just pick up where it left off, there's now an option on here that'll say resume test, and you just select that and it will grab the last test that you ran and pick it up exactly where it left off. Your other option is you can pick any interval in a program and pick it up from there as well. The one other thing I wanted to mention that somebody had asked about is how would you cycle a product on and off during a test? Is there an automatic way to do that? And the answer is no, there really isn't a function in here that would allow you to say ramp to a certain temperature and start cycling a product on and off at a half a hertz or something like that. So the way you would do that in a program if you wanted was go to the temperature you desire, insert a step, and we're now at 85 degrees C. We're going to soak there for just say 5 minutes. So if we wanted to turn a product on and off in minute intervals, we would simply, for step 2, turn it on, go to step 3, turn it off. I forgot to add in the minute. So this will keep it on for 1 minute. So your aux relay for 1 minute. And we're going to turn it off for 1 minute. Insert another step. Turn it back on for 1 minute, and so on. So you just create 5 separate profiles like that to give you on and off for 5 minutes. The same type of thing if we want to do a cold start on something. You drive it down to your temperature, say minus 40. You stay there for 15 minutes. Create another interval, say 1 minute, where you turn it on, and then you could turn it back off in another interval and continue on with the test. And I'm just going to say no, we don't want to save that profile. One of the other things I wanted to expand on a little bit is just some of the options we have for saving data. And again, to access the graph or paperless recorder, you just select the graph icon. It'll pull up your test data. This is always saved on the hard drive. You can turn on different channels, different sets of data, and display it the way you want to import into a test report. And I'll show you the few different ways of doing that. So first way is we can save this as a bitmap, which is just a picture. So I've given it a name. I'm saving it to a flash drive. We're saving it as a bitmap. So if we save, it just downloaded that to the flash drive. And we'll look at that a second on the flash drive just to show you what that looks like. So this is, we're no longer in the controller. This is simply a bitmap. So you can now take this picture and insert it into your test report. So the other way we can save this data is save it as a CSV file or a comma-separated values, something you can import into Excel. So we would just give this a name. And this time we would select CSV file. We'll save it to the flash drive. Select Save. So right now it's sending all of this data, one data point each, 6 seconds to that flash drive. And if we look at it'll open up in Excel. So now what we have is the date of the test, the time, and then each of those variables that we have displayed on the screen. If we don't want all that data, or perhaps want more, you just simply turn on those channels. So I will we'll get rid of the humidity. And then if I zoom in on just a smaller part of the data and save it, now it will only save from this point to this point. It will not save that whole test. So you just go save as. We'll call it example 1 again. Save it. We'll overwrite it. And you can see it took less time because there's so much less data here. Go back to the flash drive. So now, even though this was a humidity test, because we turned it off in the graph, it's no longer there. So now you just have your PV1, which is process variable 1 temperature, and then also set point 1 temperature. Before we also had PV number 2 channel on the controller, humidity, along with SP2 set point 2. And then we can take this data if we wanted to and create a graph. So I'm going to select scatter plot, and now it'll graph out that data just like the graph does. The one other thing I wanted to mention is we also have an export function that gives you a little more capability of customizing the data that's saved. And I'll just walk you through this a second. So it's going to ask you what channels you want to save. So previously we did process variable for the air temperature, set point for the air temp, and then humidity, we could do set point and process variable. Any monitor channels, you could export those as well. And then also the information from the refrigeration system. So if you wanted to send this into the factory, for instance, and wanted to include all of the discharge temperatures and compressor temps, you could include that. Sorry about the noise. We'll fix that in a second here. So you pick your beginning date and the ending date, and then this gives you the capability of changing the interval. So when you just save it as a CSV file from the graph, it saves it every 0.1 minutes or 6 seconds. And if you have a test spans weeks, months, and you don't want something every 6 seconds, this gives you the capability of increasing it. So if we wanted a data point every 1 minute. Bear with me just a second. I'm going to try and fix the background noise we have here. All right, sorry about that. We'll try and, we're not sure what's going on with the noise. So anyway, this will just give you a data point every 1 minute instead of every 6 seconds, so that you can control that file size a little bit, if you will. We talked about it last week. With a lot of these tests, what you can do is press the flags icon, and that'll give you when you start the test and when you ended it. So when you go to export, that gives you the beginning and ending of your test. So that clues you in when you should start that export and when you would end it. The other thing you can do is, especially if you're sharing a system with a lot of people in a lab and you have your particular settings that you like. So in this case, if you like your temperature set point in green and red, and you like the scaling and background colors, a lot of these settings, if you want to save your own particular settings, you can save this as a graph view setting. So if we saved a set of graph view settings, now this is going to save my settings just like you see here. So now if anybody comes in and changes them, it'll save this. And it also will allow me to save this particular graph. So if I want to go back to it at any time, say I have my customer coming in and I want to be able to show them 5 or 6 sets of data without having to zoom in on it and scroll it and find it, I can simply save those, and then see if I can find the one I just saved. And then it would allow me to come back to this at any time. So there's 2 purposes of that. All right, now if you will, if you're following along with a demo, go ahead and click on the setup icon, and we'll just run through what some of these different functions are. So what I did is click on setup, and then there's tabs along the top here. So go ahead and touch or select system setup, and you'll see you can change between Celsius and Fahrenheit. There's a screensaver time. You can have the light automatically go off if you want. Anytime it's set to 0, it's disabled. So if we wanted the light to switch off after an hour of being on, we could select that there. Confirm stop key press. Anytime we stop, it'll ask you if you want it to, are you sure you want it to stop? The key beep, if you're in a noisy lab and you want it to beep each time you touch it, you can turn that on. This manual mode ramp protection, I'm going to say it's hard to explain without getting into a lengthy discussion, so check it out in your manual. When you run a manual test, if you have that selected, which I recommend, it will start the ramp at whatever temperature the chamber is currently at. Process alarms are limits of the chamber. So we generally set these in a deep configuration at the factory to protect the chamber, but you might want to further limit your system. So if you know you're only testing electronics and you never want a chamber to go over 120 C, for instance, you could change the process alarms to 120, hit save, and now nobody will be able to program in anything over 120. And if it hits 120, it's going to shut the system down. And then there's similar limits for humidity and product temp as well. This is the range that we allow you to program in humidity, so generally something right around freezing and boiling point. Up here higher on the screen are some of the functions that you might need for Windows. So for instance, if you wanted to add in a network printer, this is where you would do that. So it just simply gives you an access point into Windows, and then from there it'll just pull up Windows and give you the functionality you would find in Windows of adding a printer or of updating the operating system. So if we select this and we're plugged into the network, it goes out to Microsoft. updates that Windows 7 embedded and adds in all the most recent features and security patches. Regional language settings, just if you wanted to change from into a different language. Up here, there's a calibrate touchscreen, and the reason for that is if you're in a lab where you have different people of different heights, or some people use the controller sitting versus standing, you might find that where you're touching is just a little bit off from where the software thinks you're touching. So what you can do is set it up for your height and calibrate the touchscreen, and that'll help bring the point to where you're touching on the screen. And what happens, the demo version here doesn't have it, but as soon as you touch that, a target will come up, and you just simply press the center of it. Another target will come up. It'll do that a few times just to calibrate it for your line of sight and whatever device you're using to touch the screen. If you ever walk up to a controller and it's not accepting any touches, you can automatically get into this calibrate touchscreen simply by holding your finger down on the screen. It'll automatically enter that and then recalibrate the screen for you. Couple of settings down here. There's a RSA time. It stands for Refrigeration System Anticipator. And what these are used for is if you're running a program at a hot temperature and the next step is a fast zero-time ramp to a cold temperature, this will anticipate it and start the refrigeration system in advance. So if I set this to 1 minute and my profile is 85, hold there for a while and then go to -40 as fast as possible, 1 minute before the cooling cycle, the refrigeration system will kick on in a bypass mode. And that way, at the end of that minute, it'll be all warmed up, ready to go for when it enters that cycle. So it's just a way to give you faster ramp times so you're not waiting for the refrigeration system. Aux cooling parameters. This is for an LN2 boost and just sets us up on a duty cycle. So in this example, it's set up for 6 seconds, 25% of the time. So it would come on for 1.5 seconds, off for 4.5, on for 1.5, off for 4.5. So that's just a way to adjust that. Your system time up here should be self-explanatory. Power fail recovery. The default mode in the 8800 is just to pick up where it left off. If you don't want that, you select that option, and you can have it instead of restart, you can put it into stop mode, hold, or even say, if the power is off for more than 5 minutes, then I want it to restart at the beginning, knowing that if the power's off that long, you've lost your condition, and you just want to go back to the beginning. With any of these things, if you want a little more information on it, we do have, you obviously have your full paper manual, but also online here there is a brief version of the manual that has each of these topics. So we're looking at some of the setup stuff right now. So there's a description of all of these items in the online manual as well. There's a safety stop that we built into the software, and this was something for a particular customer. They were having issues with, they would be at a cold temperature profile, and the users were instructed if a product fails during test, go in and pull it out. And what was happening is they would open up the door, it'd be -60 degrees, they'd get a bunch of condensation on all the products. So what they wanted was a way to, when the user hit stop, instead of stopping and allowing them to open up the door, it would first go to a safe temperature and then allow them to open up the door. Down here on a lot of our systems we have a door switch, And this just allows you to configure what you want to happen when the door is open. So for example, if you want it like your refrigerator where the light comes on, you just select that. Okay, next tab over, control parameters. And if you're familiar with different controllers, these are called PID settings. In the case of Thermotron, we only have PI settings, or proportional and integral settings. And the basic explanation I can give you on these is the proportional band is kind of the coarse adjustment. The integral times are more of a fine adjustment. So the proportional band, what this means is when we have an 8° C proportional band, and let me just give you a little sketch here. So if we have, here's our desired set point of 85 degrees. What the proportional band is a band that's 8 degrees off of that. So we would have one, try to make that a straight line. We would have one that's 8 degrees separated from that, or in this case, 85 is our set point, so 77 would be our proportional band. And what happens is when you enter in the set point of a fast ramp rate or a 0 time interval, what's going to happen is the system's going to go at 100% throttle all the way up until it hits that proportional band. So in this case, 77. There we go. So it's going to go 100% throttle until it hits the proportional band, and then once it hits it, it's going to start backing off, to give you something like that. So if you make that proportional band bigger, let's say we put in 20 degrees C, then what you're going to get is same 100% throttle until you hit the proportional band, and then it's going to start backing off at that point. So it will give you probably a smoother ramp into set point, but it's going to take longer because it backs off much earlier. On the same note, if you have a very small proportional band, let's say 2 degrees C, now what's going to happen is it's going to go 100% throttle right up to that proportional band, or 83 degrees C, and then it'll start to back off. And if it's too small, it's not going to have enough time to back off, and you're going to get some overshoot, and then it'll try to come back in and more control. So that proportional band gives you the ability to decide how hard do you want the chamber to drive, or how close to set point do you want it to drive before it starts backing off. So the classical reason to adjust this is if you're getting too much overshoot, where you want it to start backing off quicker, or you're seeing it and it's just taken way too long to get set point and you really don't want it backing off so quick, then you can adjust that. So the other setting is the integral time. And what these are used for is it determines how quickly the throttles change, or how sensitive the throttle is once it's within the proportional band. So best analogy I can give you is you're on the highway doing 70, and you notice that your speed has drifted off to 65. So the natural way of doing it is slowly easing back in the throttle, get yourself back up to 70, and then slowly ease back off. And that's kind of what the chamber tries to do. If you have these integral times too small, and the smaller they are, the quicker the throttle reacts, it would be like being on the highway, you see your speed drift, you're down at 65, so instead of just easing into it, you slam on the gas. And now you instantly jolt up to 100, now you realize you're going too fast, you slam on the brakes, now you drop down, and you get something, oscillation, where you're not easing into set point, but you're jumping all over the place. So in a chamber, that might look something like this. And if you looked at the throttle on the graph screen, you would see it jumping up and down a lot. So the way to correct that, you would make that integral time larger. It'll dull the throttle and settle out some of that oscillation. Also in the control parameters, you've got limits on each of the channel. So if you wanted to artificially limit the power of the chamber or the ability of how fast it goes, you could drop the limits down to a smaller amount. So in this case now, instead of all 10,000 watts of heat being able to come on, it would limit it to 50% of that, or 5,000. There's also similar parameters for humidity, and then also some parameters for load temperature, or PTC. So the biggest one you'll use for PTC is this offset. And if you weren't with us last week, or you haven't used product temp control before, generally we select, or we configure these from the factory around 10 degrees C. And how that's used for product temp control is, in green is our desired product temperature, going up to 100 degrees C, and the air temperature is going to overshoot that. And this amount of overshoot is determined by that temperature offset. So this is exactly at 10 degrees C. So we put in 100 degrees C, the air goes to 110 because we set it at 10. If we were to set this at 20, the air temperature would go to 120, which would get your product to the desired temperature faster. If we decrease this, it would to 5 degrees, it would set the air temperature to 105. You would see this go up to 105 and then hold there, and it would just make the product get there a little bit slower because you have less temperature offset. We do have the ability to use multiple groups of parameters. So if you have a particular test that you've tuned everything, you want to save those parameters, you can save them in a different group that everybody else is using in your lab. So we could set these up, group 4, and just use these anytime you run a particular test or your particular test. So when you run in manual mode, for instance, you would now see a section here where it allows you to select a particular group of parameters. Same thing with a program. If you have a program where you want to run one part of a program with one set of control parameters, and maybe in a different part you want a larger PTC offset, you could switch between different groups. You can also save a set of parameters for a particular test. So if I select Save As, the test we wrote earlier is Test 1. So I'm about to save a control parameter group called Test 1. Now, anytime I run a program called Test 1, it will automatically grab that particular set of parameters. So now you know if you've tuned in a particular test, you save those, it'll always go back and grab those. Even though your coworker may have gone in and changed parameters, you've always saved kind of your golden standard as part of that particular test. Next tab over is the computer networking settings. We've got generally 2 computer I/Os on each chamber. One could be a GPIB. There's always a Ethernet port on it. Here's where you'd find that IP address. And your options for controlling a chamber remotely, I'll show you a few different options. So one of the options we talked about last week is VNC. And we've installed VNC on every 8800 controller that has Windows 7 or XP Pro on it, so I'll say everything within the last 10 years. And what VNC does is allow you to control the chamber completely from a remote location. So we've got customers, they have equipment in Asia, they want to be plug in, look at test data, start and stop it, look at refrigeration data. You can do that using VNC. We have other customers, they've got critical tests running over the weekend, don't want to drive into the factory on Saturday and Sunday to check on it, so they set up VNC so that they can check on it from home. So to set this up, we've got a few passwords that you would enter in. So in this example, if we wanted to turn on VNC just for a week, you would go into the 8800, under Access, type in all capital letters, run VNC, select Enter. If this had VNC installed, it would turn on VNC for a week. And then there's a way to stop it, there's a way to get into the configuration of that, or you could turn it on permanently to allow access. And again, that's complete access remotely. So you can start and stop it, download data, create graphs, anything you want, just like you were actually standing at the chamber. The other thing we have built in is a web server, which is a view-only access. So it just gives you what the chamber is currently at, lets you see what's going on, but does not allow control. And then the third option would be we have a software package called Thermotron 2, which allows you to also control multiple chambers from one computer. And in general, I would say if you have all 8800s in your lab, VNC is a great way to go because it doesn't force you to learn a second software. It gives you all the functionality of the 8800. If you have a lab with different controllers in it, so you have a handful of 8800s, some 3200s, maybe some older 7800s or 6850s, then Thermotron is generally the way to go because some of those older controllers or more basic controllers don't have VNC capabilities. And with these, you can still certainly stop and start chambers, write profiles, but to be honest, it's a software that was written over a decade ago, so it's a little bit antiquated. So if you do have the ability to use VNC with all 8800s, generally the nicer way to go. Service messages, this gives you the ability to have service messages pop up. So a common one might be change the humidity filter. You can base that on humidity runtime. Say you've discovered that after 500 hours the humidity filter gets used up, hit reset, and now after 500 hours a message will pop up saying change the humidity filter. We also use these for calibration reminders or even special messages that either was a customer request or something you can add in, like the door's open or a switch has tripped, and we can tie those to particular digital inputs. So anytime a digital input's tripped, a message would pop up. Next tab over, channel auxiliary names. these allow you to just change the names of the channels, change the names of auxiliaries to give it something meaningful. So for instance, earlier, when we turned on the PTC channel, it came up as load temp. If that's confusing to you, we could rename it PTC, and now everywhere in the controller, it'll be labeled as PTC. Next tab over is Backup Restore. So what this is used for is the 8800 runs on a hard drive. Hard drives can fail, and if you have critical tests or test data, you may choose to back that data up to ensure that you never lose it. So there's a backup wizard, and it walks you through the process of backing up that data, or you can even schedule a backup every week. So you could save this to a portable hard drive. You could save it to the network so that if that controller ever does crash, you have a backup of it, and you could restore it on a new controller. The other thing we use this for is our tech support department. In speaking with you, a lot of times it's helpful to see what you're seeing. So you can make a backup of the data, send it into our tech support. They'll restore it on their controller, and now they can see your program, all of the refrigeration pressures, all of the past data that you brought to help you troubleshoot any of those issues. One tab that I don't have on this system here that we have added recently as a customer request is something called alerts. And if you think back to when we were writing a program, and I'll just give you an example here. So if we set up a guaranteed soak with a deviation of 2, we're saying we want to hold 2 degrees C, I'm sorry, 85 degrees C plus or minus 2. And once, if the temperature drifts out for some reason, the test is just going to keep on running, and it's up to you as a user to go into the graph and look at the test to ensure it was running. We had a particular customer. They were running a 2,000-hour test at 85, and the water supply to the humidity was disrupted. So after like 3 hours, it went from 85 to like 85.2% because there was no longer water going to the system. And at the end of the 2,000 hours, when they went to check on it, realized it had run out of water right in the beginning, and they came to us and asked us for a solution. So what we did is we added in an alerts tab. Bear with me here just a minute, and I'll show that to you. And this is just out of the manual. So here's what it would look like. This is on that setup screen. There's an alerts tab. And you have the option, you would check the box, sound alarm on deviation. So if it goes outside of deviation, it's going to sound an alarm. And there's a couple of anti-nuisance settings here. So allow 0 seconds for deviations to be satisfied. So when you're ramping up, you might give it 60 seconds to get into set point, and then you can put in a setting here. It must be outside of the deviation for a certain amount of time before it alarms. So if you don't want it to trip just after a 2-second alarm, you can set this up for, hey, it's got to be out for 10 seconds at least, and then it'll alarm. And when it alarms, what it's going to do is it will it'll beep. You have the option of just continuing on and letting it run, or you can put it in a hold mode while it's out, or you can actually have it stop the test. So if you have something really critical and if it goes out, it's end of test, you could simply just have it stop and then even trigger a additional alarm. And these settings are global, so anywhere you have a deviation, it will alarm. So if you only want to ensure that you're hitting your dwells, you would want to only put deviations on the dwell points and not on the ramps. So if you're following along in the demo, go ahead and select system information. So the first tab here, if you have a DAC plugged into your chamber, this will show up. So there's your auxiliary thermocouples, your analog inputs, digital inputs. And what these are used for is if you simply have additional thermocouples or spots on the product you want to monitor, you would plug those into the DAC, and then they'll show up here and also in the graph. If you have a device that you want to track along with temperature and humidity, you can set up one of these analog inputs to track that particular item. So if you have a flow meter, for instance, with a 0 to 10 volt output, you could set it up for, okay, at 0 volts, it's 0 CFM of flow. At 10 volts, it's 5,000 CFM. And now you can use this to track your product during the test along with temperature, humidity, altitude, whatever it may be. Next tab over, refrigeration system. So almost all 8800s have transducers and sensors on the refrigeration. So this is simply monitoring them. If it hits a certain limit, it'll shut things down to protect it. And then all of this information is also saved in the graph. So if the service guy comes in, wants to see what's been happening over the past few months, all of this data is saved in the graph. On our SE line of chambers, there's also a live schematic that shows you the schematic of the refrige system and then also live values at some of the key components. There's a activity log, and this will log every single input and output into the chamber. So anytime you start and stop a test, anytime you open the door, anytime you change a setting, it's all logged in this activity log. And where I'll use this a lot of times, if I'm having issues, I suspect that something may have changed with the chamber, I can just go into, like yesterday, and see if somebody was in the lab tinkering with things or changed a setting. Or if I'm looking at test data and it was interrupted during the night, I can go in and find out if somebody opened the door at 2 in the morning, which is why the condition was lost, that type of thing. Next tab over is a control module. Gives you a live schematic of the control module and all of the inputs and outputs on it. So just another troubleshooting tool that the service engineer or your own techs can use to make sure that the control module is behaving the way it's supposed to. And then the last tab over is system information. So it just gives you a channel runtime on each of the channels, tells you your software version. So you can check your own 8800, and if it doesn't have a 2015 rev level, that indicates you have an older version, and you can go through that process of updating your software. couple other things I'll quickly show you is the configuration. So each 8800 starts off as kind of a blank slate, and then we configure it for your particular chamber or your particular application. And the way to look at that is you have the ability to view it, and you would type in view config. I forget whether it's all uppercase or lowercase, but it's view config. And then this config button will show up and allow you to look at all that deep configuration but not change anything. So here's some just general settings: product temp control, this chamber has humidity, it's a cascade system, and so on. And then we'll go in and configure all of the channels. So for instance, this one is on channel 1 is temperature. Here's where we put in the limits. We set up channel 2 as a RH with a linear humidity sensor, and so on. And then same thing with analog outputs. This is where we configure all our digital inputs and outputs. So it's where we would set, digital output 1 turns on the light, and so on. We have the ability to set up certain system events. An example of this is we have customers that will want something to turn on at a particular temperature. So we can set up a relay to turn on anytime the chamber is above 100 C, or turn off anytime it's above 100 C. We also have the capability of putting in PLC events. So if you want to set up some and/or situations, or if a particular set of events occurs, turn on an alarm or turn on a product, we have the capability of doing that. And that's all within the deep configure. So we give you the ability to view it, but not change anything. If you have a brand new controller that you would need to replace and load all of this configuration onto a new one, we could send you that configuration file, or we send it with each chamber, and you would simply go to the main screen and open it, and it would look for that configuration file on a flash drive. You open it, and it would load all of this onto a blank controller and configure it just like it left the pack. So the last topic I want to quickly cover is the thermalarm. So thermalarm is a over-under protection device, its own thermocouple. On a 8800, you could have up to 4 different thermalarms. So in this case, we just have one. If we had plugged additional ones in, you would see all 4 of them up here. And we can go in and set that up to limits of a particular product. So if we're concerned that if a particular product hits 85, it's going to fail prematurely, we could set this up. And then if anything happens in a programming error or chamber error, it's going to shut things down at 85. There's a low limit as well. There's a warning band. So in this case, at 10 degrees C, the system will start beeping, or at 75 degrees C, it'll start beeping. And then when it hits 85, it'll actually shut the system down. And then the thermalarm has contact relays on it that you can use to wire your product through, so you could shut down the product at the same time, especially if it's something that gives off a lot of heat while it's running.
All right. Well, it's a lot of information, Chris, so thank you so much. And in case you guys missed anything or something wasn't super clear, a recording of this webinar will be made available, and we will send it out to anybody who attended, and also have a link on our homepage that'll have an opportunity to view the webinar, and that way you can kind of go through the webinar yourself at your own pace and also work in the demo at the same time. So that will be made available to you.